Would you like to learn about periodicity identities from a graphical perspective? I'll quickly show you all you need to know about them and then dive into some example problems where we'll use them to find the exact value of a trigonometric function. Welcome to Understand the Math. We've created free guided notes that you can use as you watch this video and placed a link to them in the video description below. There's space in the notes for you to highlight the important concepts and to fill out the answers to the examples that we're going to do. To determine the periodicity of the 6 trigonometric functions, sine, cosine, tangent, cosecant, secant, and cotangent, it's helpful to look at their graphs. We'll start with the sine function. Sine theta completes one full cycle in 2 pi units, and it repeats when you add or subtract 2 pi. This identity can be written as sine theta plus 2n pi is equal to sine theta, where n is an integer. It can also be written in terms of degrees. Cosine theta also completes one full cycle in 2 pi units and repeats when you add or subtract 2 pi. We can write the cosine periodicity identity in terms of radians or in terms of degrees. Tangent theta completes one full cycle in pi units and repeats when you add or subtract pi units. We'll write this identity as tangent theta plus n pi is equal to tangent theta. We can also write it in terms of degrees. Similar to sine theta and cosine theta, cosecant theta completes one full cycle in 2 pi units. The graph is separated by an asymptote. Cosecant pi over 2 is equal to cosecant 5 pi over 2 and cosecant minus 3 pi over 2. This identity can be written as cosecant theta plus 2n pi is equal to cosecant theta, and it can also be written in terms of degrees. Similar to sine and cosine, secant theta completes one full cycle in 2 pi units. Secant of 0 is equal to secant of 2 pi, which is equal to secant of minus 2 pi. Our identity looks like this in terms of radians and this in terms of degrees. Lastly, we have cotangent theta. Similar to tangent theta, this function completes one full cycle in pi units. It repeats when you add or subtract pi and can be written in terms of radians or in terms of degrees. Let's now dive into 3 example problems where we'll use periodicity identities to find the exact value of a trigonometric function. We'll first find the exact value of sine of 750 degrees. Our periodicity identity tells us that sine theta is equal to sine of theta plus n times 360 degrees. Since 750 degrees is greater than 360 degrees, we'll need to subtract multiples of 360 degrees until the remaining angle is between 0 and 360 degrees. Let's go ahead and do that. We have 750 degrees minus 360 degrees, and that's equal to 390 degrees. That is still greater than 360 degrees, so we'll have to do this process again. 390 degrees minus 360 degrees is 30 degrees, and that is between 0 and 360 degrees. So we can write that sine of 750 degrees is equal to sine of 30 degrees, and that's equal to a value of 1/2. Let's now find cosine of minus 9 pi over 2. From our periodicity identity, we know that cosine theta is equal to cosine of theta plus 2n pi. Since minus 9 pi over 2 is less than 0, we'll need to add multiples of 2 pi until the remaining angle is between 0 and 2 pi. Let's go ahead and do that. We have minus 9 pi over 2, and we add 2 pi. That's equal to minus 9 pi over 2 plus 4 pi over 2 gives us a value of minus 5 pi over 2. That's still less than 0, so we'll do it again. Minus 5 pi over 2 plus 2 pi is minus 5 pi over 2 plus 4 pi over 2, which is equal to minus pi over 2. We're almost there. We need to do it one more time. We have minus pi over 2 plus 2 pi. This is equal to 3 pi over 2, which is between 0 and 2 pi. Our periodicity identity tells us that cosine of minus 9 pi over 2 is equal to cosine 3 pi over 2, and that's equal to 0. In our last example, we'll find the value of tangent of 585 degrees. You might want to stop the video and do this problem on your own, and then come back and check your solution. Our periodicity identity tells us that tangent theta is equal to tangent of theta plus n times 180 degrees. Since 585 degrees is greater than 180 degrees, we'll need to subtract multiples of 180 degrees until the remaining angle is between 0 and 180 degrees. Let's do that. We have 585 degrees, we subtract 180 degrees, and we get 405 degrees. That is greater than 180 degrees, so we'll do it again. 405 degrees minus 180 degrees is 225 degrees. That's still greater than 180 degrees, so we'll do it once more. And we get 225 degrees minus 180 degrees is equal to 45 degrees. Our identity tells us then that tangent of 585 degrees is equal to tangent of 45 degrees, and that value is equal to 1. I hope that you now have a better understanding of how to use periodicity identities and feel ready to do some of these problems on your own. If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.